Okay, we're here for video lab number 10 today. We're going to be meeting today's team, and who might you be?
Amanda.
Brian.
Richard.
Kristen.
Okay, and who from the audience can tell us what are we trying to find out today?
Specific gravity?
Yes, specific gravity. We need a definition for the word. What do we mean by specific gravity? What is it?
Relative density.
Relative?
Relative density.
Well, that's another way of saying specific gravity, but there is an actual definition for the words. What does the definition say? That nervous tick that you had in your head that we picked up on it.
The relationship between weight of an object and the weight of an equal volume of H2O.
That is correct, okay? We're going to be making a comparison, a ratio between two things. Now, if you know the specific gravity of an object, you know something about it. You can make a prediction about it. What can you predict if you know the specific gravity of something? Yes?
How fast it can sink in water?
Well, that and what else?
Its weight.
No,
Density.
no. What do you know about the object if you know its specific gravity?
Of volume.
No.
If it's more than one or less than one.
Then what happens?
If it's more than one, it sinks, and if it's less, it floats.
Yeah, so in other words, you know if the object floats or sinks, if you know the specific gravity. How about if it's equal to 1? Then what happens?
It just floats in the middle of the water.
Yeah, wherever you place it in the water, it will just stay there. It won't rise, it won't sink. Okay, good. All right, so we know the specific gravity. We know whether it floats or sinks. And according to the definition that we just got before, we're going to be comparing two things. So to do this, we have to know how much does the object weigh, how much space does it take up, how much space would the same amount of water take up, and how much would that water weigh. And when we compare those two weights, that gives us specific gravity, okay? So what's the object that we're comparing today? Who has the object? Do you have the object?
Brass.
Okay, a piece of brass. So the first thing that we need to do with that is to weigh the brass. So if you would do that.
What?
What? It's like somebody shot you in the mouth right over here. Look, big match coming out of you. What you got, Brian?
68.5.
68.5. And if you would write that down next to the water weight, 68.5. So we have half of what we need. How will we figure out the volume of that metal in an equivalent volume of water? What do we have to do to get the volume of the metal using water to get the volume? Tell us the procedure.
Put the brass inside of an overflow cup.
Yeah, let's see the cup. Who has the cup? Okay, so that's the overflow cup. And then, Antoine, what are we going to do with that cup?
Fill it up with water
Yeah.
while holding your finger over the nozzle. And then placing it near the sink, let it all drip out, and then put...
There's that nervous tick.
let all the water go inside the littler cup.
How do you do that? How's the water go inside it?
It overflows
From doing what?
from the metal inside of it.
So in other words, in order to make the water overflow, what do you have to do?
Put the metal inside the water.
Okay, and the water that comes out is equal to what?
The volume,
Of the,
brass.
right. Okay, very good, you got it. Now, when the water comes out into the beaker, that's not going to be the weight of the water that's in the beaker. How do we get the weight of the water that's in the beaker? What do we have to do there to get the weight? Hello? Yes?
First you gotta weigh the beaker, and then once you get the water in the beaker, well, you gotta like record it, and then when you get the water in the beaker, you gotta weigh it again,
Right.
and then you gotta subtract the weight of the beaker from the beaker plus H2.
That's correct. Okay, so what we need to start with is the weight of the beaker. So if you could pass that over to Brian, and Brian, weigh that up one more time for us. And what'd you get?
30.2.
And you got to remember that because we're not going to write it down,
Right.
okay? So what's the weight?
30.2.
Very good. Okay, now, if you could pass the beaker. You're going to do the water for us? Pass the beaker and the metal over to Kristen. Kristen, you know what you're doing, right? Okay, good luck. We'll follow you and see if your technique is correct. And remember that piece of paper up there has got a 510 clearance. You don't want to hit it. Don't be scared, it's only water. Okay, and the water that's coming out right now is equivalent to the volume of that piece of metal that you just put in. Okay, very good, Kristen. Now what I need you to do is to just dump the water and the metal out into your hand and catch that and leave it there because we don't need it anymore for this part of the lab. And just bring us back the beaker with the water. And we have to weigh the beaker with the water. Once again, this is the first person all day that has done the experiment at the sink correctly. Every group before you has forgot to put their finger over the nozzle. And what'd you get?
39.2.
Okay, now we have to take that weight and subtract the weight that he had to remember before. You remember that weight still?
30.2.
Okay, and Richard, if you could plug in those two numbers, that will give us the weight of the water.
9.0.
And if you would write down next to water 9.0. Okay, so now we have the weight of the water and we have the weight of the metal. What do we have to do to get the specific gravity now? Yes.
Divide the weight of the water by the weight of the metal. Divide the weight of the metal by the weight of the water.
Yes. Okay, remember last time you got so confused on this?
I know.
Okay, and Richard, this is again where you come in, so if you can plug those two numbers in and give us the specific gravity for your brass.
7.61.
And if you would write down next to specific gravity 7.61, and Amanda, if you can then turn around your paper so we can see what it is that you've written. Okay, so a piece of brass, any piece of brass, not just this piece of brass, has a specific gravity of 7.61. Let's talk about that number for a second. 7.61, who can round that off to the nearest whole number for us? Kevin? 8. Now here's your dog question. If you know that the specific gravity of a metal is 8, you know two things about the metal. What's one thing that you know about that metal if its specific gravity is 8?
It'll sink in water.
Yes, because it's greater than 1. Okay, now let's talk about the number 8. What is the number 8 really telling you? Remember, this is a ratio number. So you're comparing it. What's the 8 really mean? So tell me another way of saying it.
The 8 is 8 times more than the specific gravity of water.
Okay, and therefore it also, use another word besides specific gravity. The metal is 8 times what? More than the water for the same volume.
Density.
No, not density.
Relative density.
No.
Greater.
Greater in what? No, you haven't compared volume. Greater in weight. Remember, we were doing the weights. So the number 8 simply means that the brass weighs 8 times more than the same volume of water. Any piece of brass that you end up with will be 8 times greater than the same volume of water. Okay? Okay, you did a good job on this. Now, second part of the lab has to do with an experiment that this group is going to do up here. And you guys are going to make some predictions based on the specific gravities that you came up with in your metals. Now, they used brass, but the rest of you used other metals. So what were some of the other metals that you might have used? Yes? Aluminum. And what's another metal you might have used? Copper. And one more. And one more. Iron. Okay? So what we're going to take a look at right now is the different ones that we have, and then we're going to do some experiments with it, so we'll back off and come back in a second. And we are back, and we're standing in front of a tub of water. Okay, that's what that little fish tank is there. Now, the members of our group have different pieces of metal that they have in their hands right now, and they're going to be doing some experiments where they're going to lie the metal at the top of the water. They're going to let go of them at the same time, and then we're going to try to predict the rate at which they might hit the bottom of the water. And the first person up to the plate is Kristen, and she has 2 pieces of brass, right? So that's the metal that you actually used in your experiment. And what you guys over here are going to do are going to predict. She has one in her left hand and one in her right hand. And you're going to predict which one, her left or her right hand metal, will hit the bottom when she lets go of them. So who would like to make a prediction from this group over here? And what would you predict, sir?
They're both going to hit at the same time
And why is that?
because they're the same kind of metal.
And therefore, what do you know about it?
They have the same volume,
Well, not the same volume,
weight,
not the same weight.
um,
Think about what this lab is about.
specific
That
gravity.
is correct. Okay. Let's see if Josh is correct in what he said. As we set up for this, I will give you a count of 3, Kristen, okay? And at the count of 3, you will let them both go and make sure that you do at the same time. Okay? 1, 2, 3. And can you tell us, Kristen, which one hit first?
They both at the same time?
So Josh's prediction was correct. Okay, so making sure that none of you have your watches on right now, if you could fish out the brass from there. Kristen is actually going to get into the tub right now to get it out. You got them both? Now you can appreciate what I went through. Okay, you want a blanket or anything? Okay, now, who's next up on there? All right, now, Richard has, according to our numbers up here, let's take a look at the specific gravities. We just used brass, which had the highest specific gravity of all the group. Right now, we're going to use aluminum, which has the lowest. So in Richard's hands right now, show us the 2 pieces of aluminum. He's going to be doing the same thing with aluminum, and it's going to be this side that's going to make the prediction as to which you think are going to hit first, the left hand or the right hand, and what do you think, Miss?
They're going to hit at the same time.
And why might that be?
Because they have the same specific gravity.
Because why?
Because they're the same kind of metal.
Yes, let's see if you are correct in that prediction. Richard, are you ready? Okay, you want to put them flat at the top. Okay, and on the count of 3, you're going to drop them. Class, why don't you give him the count of 3?
1, 2, 3.
And which one hit first, Richard?
They hit at the same time.
Same time. So again, the prediction is correct. Okay, could you now fish out the aluminum? Okay, and now, who's next up? Brian? Brian has the original metals that we just dropped in. He has a piece of aluminum and a piece of brass. Show us which one's the aluminum.
This is aluminum.
Okay, and which one's the brass? Okay, and you guys over here, once again, are going to make a prediction. He's got aluminum, he's got brass, and Ivan, you're going to make the prediction for us? Which one do you think will hit first?
brass,
And why is that?
because it's heavier,
It's not heavier.
has more than one,
Nope.
something like that.
Who can help him out? Why is it going to hit first?
It has more specific gravity.
Yes, it has a higher specific gravity, okay? Let's see if that is correct. Okay, are you ready, Brian? Okay, remember you got to drop them at the same time. Show us which one has the brass. Okay, so that's the one we expect to hit first. Okay, you ready? Okay, class, you know Spanish? Yes. Give them the count in Spanish. 1, 2, 3. And which one hit first? So you were correct, Ivan, in your prediction, even though you weren't exactly sure why it was going to do that. Okay, pull it out. Okay, and now we come to Amanda. Now, Amanda has some copper in her hand. Let's take a look. Hold your palms out. She's got a chunk of copper over there and a little copper BB over there. So we're going to put the BB up against the chunk, okay? And you guys over here are going to predict which piece you think is going to hit first. So which piece do you think is going to hit first?
They're going to hit at the same
And
time
why might that be?
because they're the same metal and they have the same specific gravity.
So let's see if that is correct. Okay, Amanda, you set? Amanda looks like she's also going to dive in. It's a 6.6 difficulty on the Olympic scale. Show us which one's got the BB. Okay, so the BB, it's always hard for us to find the BB. So here we go. I'll give you the count, Amanda. Are you ready? All set? Okay. 1, 2, 3. And which one hit first? Same time, okay. And we actually could see the BB come down this time, which is the first time today that I've been able to see it. So your prediction was correct. And what that prediction means is that it doesn't matter how big or how small the